So this is one of the culmination or culminating activity or procedure for your histopathologic technique. So from tissue processing, after you're able to fix your tissues and then up to the point that you're able to embed them, you are now ready for the fundamental technique that allows you to cut tissues thin and um, that is important for histologic examination, histopathologic examination under the microscope. So, what is a microtome? So, for this lecture, we would aim that you are able to describe the principles and purpose of microtomy and the different types and explain the significance of appropriate section thickness and temperature in tissue sectioning. So, feeling cute might form ribbons distance. So, what is microtomy? So, think of it as like a culinary artistry in which instead of cutting or julienning carrots, you are actually slicing biological tissues into micron thin ribbons that even ants will trip. So microtomy is essential in both paraffin and frozen sectioning. So that's for clinical and research histology. So ano ang ibig sabihin ng microtomy as a whole? It's when you slice sections of biological tissues. Sorry, when you slice biological tissues into very thin sections, and then you will use those slices and put them into a slide eventually and then stain them. So the core tool in microtomy, of course, is the microtome. So it in principle it advances and slices the embedded tissue block. So um, we have several types of microtomes. So not all microtomes are created equal. So they have different approaches, and these are usually the main types of microtomes that you will see. So they have specific purposes in different expected tissues in the laboratory. So you have your rotary, base sledge, rocking, sliding, and ultramicrotome. So rotary microtome, one of the most common, is also termed as minot, because it's from the one who discovered or created it, and it's the most common, especially for paraffin embedded tissue. So these are different types of microtome. Okay. So before we go and discuss the different types of microtome, let's mention muna what are the important sharp things in the microtome. So we have your microtome knives and blades. So we have disposable blades and we also have glass knives, which are usually ginagamit sa ultramicrotomy for electron microscopy. And diamond knives are for high precision, expensive, especially if you want it perfectly cut without distortion. So you can see here different knife profiles. So what are knife profiles? So just like in face, so it's like your side profile. So that's how it looks like. So you can see planar concave. So it's fragile but sharp. This one is a wedge, and this chisel is robust for rough tissues. And we will mention some other knives in the coming slide. So think about thickness control when you are thinking about the microtome knives. When you adjust section thickness, that's through microtome control. So it affects what you see under the microscope. So if it's too thick, of course, light will not pass, and if it's too thin, it's like almost transparent. So you miss the structure. So the difference between certain sections, for example, paraffin sections, the ones that you made in the lab, and yung frozen sections, they are quick but lower yung resolution. But paraffin, medyo long yung process but higher resolution. So, aside from knowing the knife, you have to correlate that with the type of block that you're gonna use. So that's microtome knives and blades. So this is a wedge knife. It's for routine purpose. And the biconcave knife naman, introduced by Hi4, is usually present sa mga rocking microtome and sledge microtome. So that's for um, microtome knives and blades. So kung dito, you can compare the wedge type with planar concave. And the chisel. So meron siyang parang specialized term that um, is for special types of blocks. So that's knife, different types of knife. Okay. Disposable blades or disposable knives. So they are like um, the common knives being used for modern histology labs if the laboratory can afford. So they are pre-sharpened, they are sterile, and ready to use. So parang yung ginagamit nyo, I mean, think about it as just like the one you use for shaving. So diba, ready na yung blade, sterile na sila, and you'll just use it. So they have clean cuts around 2 to 4 micrometer in sections, but they're expensive kasi disposable. So ulit-ulit mo siyang kailangan bilhin. So they are available in different profiles, pwedeng high or low. So depending on your tissue type and your blade holder. So meron din tayong tinatawag na tungsten carbide knife. So these are metal na non-magnetic knives. So they are great when you have a specific imaging technique that you want to elicit. And they are harder than steel. Imagine as kitchen knife, tapos convert ka to a katan. Parang that's the degree of jump from the normal microtome knife to a tungsten carbide knife. It's said to be able to cut 30,000 serial sections of undecalcified bone per sharpening. So, meron siyang approximately 30,000 slices for bone per sharpening. So, that's uh, especially useful if we are um, trying to check research and orthopedic histopathology where the bone quality matters. So that's tungsten carbide knives. Okay. Now, let's talk about angle. So aside from the type of knife or type of blade that you will use in the lab, you also have to take note of the angle. So meron tayong three major angles that you have to consider. The rake angle, the bevel angle, and the clearance angle. So it's like geometry, but with blades. So it will make or break your tissue sections. So the clearance angle is the actual angle here between the lower bevel of the knife and the block surface. Lower bevel and the block surface. So that's clearance angle. Lower bevel, block surface. So clearance angle. So that's like how the knife will be glided into the path. So if we are using paraffin blocks, it's ideal to have 2 to 4 degrees angle. But if you are using frozen tissue blocks, so it's recommended to have 5 to 7 degrees angle for because mas resistant ang ice. So you have to have a higher angle. Well, the rake angle naman, this one, so bevel yan, upper bevel of the knife and a line that is 90 degrees to the block surface. So if mas mataas yung angle, mas low yung clearance. So imagine if um, pinataas yung angle dito, sorry. Pag mas mataas yung angle, mas low yung clearance. So that's for soft tissue. Pag lower angle, so mas mataas yung clearance. So that's for harder tissues. So that's why it's important. The thing about angles is that you are able to parang have the ideal angle on a certain trial and error and a bit of granting method. So you don't know it pag lagi mo agad, 2 degrees. So it's not like that. You have to adjust, especially if bago pa lang in terms of microtomy. So for those of you who are able to actually perform the microtomy na, so you understand what it means or the implications of the angles of the knives are. So that's for clearance and rake angle. So what about the bevel angle? So it's also termed sometimes as the cutting angle. So yeah, the bevel angle. So it's the angle between two facets that form the cutting edge. So it's the level or where the two bevels of your blade meet to form that super fine edge. So it's like swordsmith's precision. So the ideal range is around 27 to 32 degrees Celsius. Smaller angles, sharper edges. Smaller, sharper, but also more fragile. Kasi nga, smaller. And the width of the two facets, it's recommended to be 0.1 to zero point 0.6 millimeters. So if it's too sharp on I mean, if it's smaller, that means it's sharper. It doesn't mean that it's better. So if it's too sharp on hard tissues, magkakaroon ka ng chipped blade. If it's too blunt, makakrush naman yung tissue. So you have to find the right bevel. So microtomy, you'll think it's just slicing. It's not. It requires skill. So that's why it's important. So aside from the type of knife, the angles, the different angles, so you also have to maintain the strength and the sharpness of your knife or the ability to cut tissues precisely. So you have honing and stropping. So honing, that's used to sharpen steel knives, but we don't do that in disposable blades. And it is essential for carbide or tungsten carbide na knife. So this hone, bairan, so that's the sharpening stone, and it should be placed in a non-skid surface. So dapat hawakan ng knife firmly, like this, thumb on the back, forefinger, mali. Thumb on the back, forefinger on the front. So you should move diagonal and even just like sharpening a knife, ironing a shirt, but sharp. So that's honing, honing technique. So that's important because we want to remove any nicks that are going to ruin your section. And we don't want those artifacts present in our tissues. So again, honing is like sharpening and it removes any microscopic nicks that will ruin your section eventually. So after honing, you will do stropping. So the knife should be laid at the near end of the strop with cutting edge towards the operator, papunta sa operator. And the knife is held with the forefinger and the thumb. Forefinger and the thumb. So the action for stropping is opposite of honing. So it's like polishing what is already sharp. So the stropping um, method can either be flexible or using a rigid um, structure. So the rigid ones, usually ang size ay 12 by 2 by 2 inches. And take note before you use the strops, dapat na oil siya and powdered with carborundum powder so that ma-maintain ang ability niya to polish your knife. So, um, that's for honing and stropping. So aside from that knives, we also have other essential equipment for sectioning. So we have the water bath, drying oven and hot plate, forceps and brushes, the slides and the section adhesive. So you actually have an idea because you have seen this now in the um, laboratory. So the temperature for the water bath is ideally um, 10 degrees below the wax melting point. So in this case, below the paraffin melting point. So we use distilled water with detergent or alcohol to reduce bubbles. While for the drying oven or hot plate, so we also set that to a temperature of near the wax or paraffin melting point. So that's almost 60 degrees Celsius. And if gagamit kayo ng delicate tissues like brain or spinal cord, so of course you have to use lower temperature, around 37 degrees overnight, so that hindi masira yung tissue integrity. Forceps and brushes, so you need that for the ribbons. Your hands should never touch the ribbons, and the forceps and fine brushes are your tools to manipulate the sections so that after siya na microtome, you can smoothen out the folds and the creases, and you can guide the ribbons across the blade. And also, you can use that to remove air bubbles on the water bath. Slides and section adhesive, so you use a standard 76 by 25 millimeter slides with a 1 to 1.2 millimeter thickness as recommended for strength, and you label them with chemically resistant pen or auto labeler if mayaman ang laboratory. So, of course, after sectioning out, you have to make that section stick to the slide. And you can use polyl-lysine, ATEs, or the aminopropyl triethoxylane. So this one, ATEs. So that's for bloody or mucin-rich na specimens in the charged slide. So they are quoted na paggawa, and then you just allow the sections to stay. So this is a water bath. So parang nagsuspa lang yung tissue natin. So 10 degrees below the melting point of paraffin. So around 40 to 45 degrees Celsius, because you don't want the section na matunaw yung paraffin. You have to scoop out the section on the slide. So we use distilled water to avoid mineral deposits kasi kung tap water, may mga deposits and that can be seen during staining. And then we use naman detergent or alcohol so that the water surface tension will be broken. So sometimes you add a mixture of albumin, glycerin, and thymol. So walang tutubong growth of organisms sa water bath. As I remember, 40 to 45, that can still allow growth of microorganisms. Okay. This is a sample of a drying oven, so 60 degrees Celsius near the wax or paraffin melting point. Again, pag delicate tissues, we don't want to use higher temp. So gamit lang tayo around 37 degrees Celsius. So this one is a slide hot plate. So, hindi natin siya ilalagay direct sa hot plate kasi madedestroy ang tissue integrity if ever, if of course. That's if merong ganito sa lab nyo. Okay. Next, syempre, forceps and brushes para ma-remove ang folds or mag-guide siya sa after microtomy. Okay. So this one, you can use this for preventing microbial growth. Okay, so let's go and discuss the different types of microtome. So memorize ito, the types of microtome, kasi these are your best friends, especially in exams. Okay, rotary microtome. Rotary from rotation. So this is the most commonly used microtome. It can either be manual, semi-automated, or fully automated. So rotary siya because it has a 360 degrees rotation in a advanced fine hand wheel. So it will move the specimen vertically past the cutting surface and then back to the starting point. So it's like operating with a staged rotary action. And the knife is typically fixed in a horizontal position. Again, pwede siyang manual, semi, or fully automated. So this is an illustration of the rotary microtome. So may tray, hand wheel, the lever, knife, holder. Ito yung removable section waste tray and the block holder with the block. So again, the paraffin block moves vertically past the blade and then returns to its position. And the knife will move receive the specimen. So ganun. Ito yung sample. Ito yung blade or the knife. So, vertical, di ba? So, the section is produced kasi na-hit siya no blade. And then, babalik siya sa um, old position. Pero, i-withdraw mo na siya for a certain clearance angle before siya pabalik sa taas, sa original position. So, that's why it's like moving in rotations also when you are performing microtomy. So parts, knife holder base, and knife holder. This is the coarse hand wheel and the micron adjustment knob so that you can adjust the size of your sections. So this is the rotating wheel and the safety lock. Make sure na may access sa safety lock. So these are the different rotary microtomes. So manual, semi-automated, and fully automated. So because the machine is heavy, it is stable during cutting and it does not vibrate. So it's possible to get a serial sections. And the angle of the cutting blade and the angle of the knife, cutting blade and the knife may be modified. So you can adjust that or adapt that depending if hard ba, fragile ba, or fatty ba yung tissue. So that's able to produce around 2 to 3 micrometer of thin sections, ideal for diagnostic work, and it can cut through hard or fatty tissues and even celluloid blocks. So that's rotary microtome. This one naman is the base sledge microtome. So this is a heavy duty cutter. So unlike rotary types, the knife moves and the specimen is stationary. So you can use this for larger or harder tissues like bone, brain, and eye. So it's sometimes preferred in neuropathology and research settings. So this microtome naman gives better control over sectioning force, and that's helpful if you're going to slice some tough or brittle specimen. So again, during sectioning, the specimen is held immobile and the knife glides over the top of it. Next is rocking microtome. So this is an old school legend, historical yet functional in design. So this was invented by Caldwell and Trifol in 1881. So para siyang sewing machine, sewing kit. So this is also sometimes used in cryostats and it features a certain retracting action or retracting block action. So it will pull the block away after each cut. That's why it's helpful if it's used in cryostat. So it's simple to operate. It's the simplest among the different types of microtome. It consists of a heavy base and two arms. So yung lower arm is resting in pivots and merong support column and that's attached to a certain microtome screw of the base. And the upper arm is carrying the block holder on one end using a screw and then it is connected to a lever by a certain piece of nylon or thread. So that's the rocking microtome. Rocking, Caldwell, and Trifol. So these are the different parts. So this is a Brunel rocking microtome. I think this is from a lab in UK. So you can see a rocking arm, the micrometer screw, an operation lever, a knife holder. This is the sample holder. So walang This is the sample holder, and this is the knife tightening screw. Tapos, ito yung sample holder screw. And this is the safety lock mechanism. So that's um, the different parts of a microtome. So it will produce a flat block face. Then this is an upper view. This M is when you want to control the section thickness. So bakit siya rocking? Because it's using a pivoting arm, giving it a rocking motion during operation. So it's low in maintenance and it's not very suited for high precision or very thin work or sections. This is a knife set at a proper angle. So ito yung nakita nyo kanina, knife adjusting, sample block adjusting, knob. Okay, sliding microtome. It's a classic microtome as well, just like the rocking microtome. This was invented earlier than the rocking microtome in 1789 by Adams. So stationary knife, the specimen moves. Kanina, dun sa base sledge, the specimen is stationary and the knife is the one moving. So this, the block slides horizontally, and it is still used today for celloidine blocks because it's too soft and it can be thick for rotary or sledge types. So because of the block movement, dapat you are able to control it visually, and that can be favorable for thick and delicate materials. For example, kailangan nyo for research. So the knife, again, remains stationary and the specimen will move beneath it. So that's for sliding microtome. So um, next type is ultramicrotome. Ultramicrotome or ultra thin microtome or the ultra precise microtome for electron microscopy. So this is what is used for ultra thin sections, about 50 to 100 nanometers, so like 1,000 thinner than a hair strand. And specimen is used fixed in osmium tetroxide and embedded in plastic because it allows us to visualize thin sections. So, pwede siya for organelles, membranes, viruses, kasi nga, we are gonna use electron microscope. So, anong blade? Of course, diamond. So, nothing else can survive this type of microtome. That's diamond knife only. Again, fixed in osmium tetroxide and embedded in plastic. Okay, practical setup of a microtome. So, kailangan mag-follow ng maintenance policy of the lab. Whether meron kayong gagawin daily, weekly, quarterly, yearly, dapat documented and executed. Again, risk management. And the microtome and the water bath should be ergonomically positioned so that walang strain. Adjust for the elbow height and shoulder neutral posture. So, pag water bath naman, you can use tap water, but ideally distilled water yung ginagamit natin, and it's heated 10 degrees Celsius below the paraffin melting point. So it will keep the ribbons from crumpling or sticking to each other. So blade setup is critical. So dapat it's sharp and defect free, and the clearance angle should be correct, 2 to 4 degrees Celsius if paraffin blocks. Frozen sections, 5 to 7 degrees Celsius. So if your sections are nagka-crinkle, nagka-curl, nagsistick sa blade, it's usually a setup issue. So you have to tune your angles properly. Okay. So that's microtome setup. Okay, next, sectioning. So sectioning is the part that comes after you sliced your materials and will be covered in the next video.